Hey guys, here we are, 9-1 lesson check. So using your notes from class and thinking about our discussion question today, let's solve these 5 questions. So what's it say? ABC maps the outline of a new park. Select all the types. Okay, so that's important, right? Meaning I have to select more than one. So scaling means they're all different, right? Right means there's one right angle. Isosceles means 2 equal sides, which ends up being 2 equal angles. Equilateral means all sides and angles are equal. And then acute means all the angles are less than 90 degrees. Okay, so let's investigate. So to figure out the lengths, I can find the distance between B and C, right? The distance between B and C is, so it looks like I go over 2, down 4, so that would be 2 and 4. So that distance is the square root of 20. Now what about this distance? So the distance between A and C would be, to get from A to C, I would go over 4 up 2. So 4 and 2. So it looks like I'm getting the same answer. So I'm thinking I'm going to pick isosceles because this other side is a lot longer. But let's just verify. So how far is A from B? Looks like I went up 1, 2, 3, 4, 5, 6 over 2. So that'd be 6 and 2. Nice. Okay, yeah, so that one's different, right? So I'm not going to pick, that's going to be a big no for equilateral. And I'm not going to pick scaling. Now let's investigate the angles. So it looks like this angle might be right, but you're not sure. So to verify that, you need their slopes to be the slope of AC and the slope of BC to be opposite reciprocals. So let's investigate. Let's see, the slope of AC, so to get from A to C, I went up 2 over 4. So that's rise 2, run 4. The slope of BC, let's do that. We'll go from B to C, so I go fall 4, run 2. So fall 4, run 2. Interesting, right? Those are opposite reciprocals. So that means, yes, they are a right angle. Which means, yes, it is right, but then that means, no, it's not acute because not all of the angles are less than 90. And one of them is a right angle. So it's a right triangle, not an acute triangle. Question number 2. ABC maps out the outline. So this looks like the same figure. Now they want to know what the area is. Okay, so we already established this distance between B and C is the square root of 20. And this distance between A and C is the square root of 20. And that's a right angle. So that's a splat. That's an altitude. So the area of a triangle is 1/2 base times altitude. So we can call this the base, which we know is the square root of 20. And this the altitude, which we know is also the square root of 20. Okay. So interesting, right? Square root of 20 times the square root of 20 is the square root of 400. But the square root of 400 is, you guessed it, 20. So our answer would be 20 divided by 2 or 10. There it is. Nice. Question number 3. Let's take a look. DEFG models the shape of a pig pen. What is a perimeter? So the perimeter is adding up all the sides, right? So let's figure out what the sides are. So the distance of FG would be, if I went from G to F, I went over 1, up 3. So that's 1 and 3. Now let's take a look at this side. It looks like here I'm doing the same thing. So those have the same slope, right? They're parallel. I went up 3 over 1. So it's the same thing as this one. The distance between D and E looks like it's that, which is the same thing. Now, what about this longer side? What is the distance of these two longer sides? Let's take a look. DG and the distance of EF. It looks like we go up 1 over 4. Here you also go up 1 over 4. They're definitely the same. So like a 1 and a 4. So what do we got? We got, this would be 9 plus 1, or the square root of 10. This would be 1 plus 9, or the square root of 10. This would be 1 plus 16, or the square root of 17. Kind of got the same situation here. So how many square roots of 10 do we have? It looks like this, right? We have 2, and we're going to add these all up, right? Each of these we would think of as we did them separately. So I have 2 square roots of 10, and I have 2 square roots of 17. That is my perimeter. Nice work. Question number 4. Select all. Okay, so we got to be careful, meaning there's might be more than one answer. All the correct descriptions of the relationship between DE and FG. So DE and FG. Okay, so they definitely look parallel. So we like that one, right? And they definitely look equal length. Now we'll verify that in a minute, but proportional, that means the sides make the same ratio. I don't really like the context of that proportion. Usually it's just like, is this side proportional to that side? We don't really talk about that in the same shape. So that one's a little bit weird. Are they perpendicular? Okay, so do they meet at a 90-degree angle? It looks like they're parallel. They're never going to meet. All right, so the definition of that, meet at a 90, like no, won't meet. Okay. Are they collinear? The definition of collinear means on the same line. Okay. So like here's 2 points that are on that same line. Those 2 lines are 2 totally different lines. This line and this line are just totally different lines. So I'm not going to click that one either. No. Different lines. So let's investigate a little bit deeper about, are they parallel? Well, to find out if they're parallel, we have to find the slope of DE. So let's do that. I rise 3, I run 1. So rise over run. Now let's find the slope of GF. So I rise 3, run 1. All right. So they do have the same slope. So parallel means same slope. And yes, they have the same slope. So I'm going to pick that one. Now it says, what about equal length? So let's find their distances. The distance of GF and the distance of DE. That's the same number we collected, right? This is 1 and 3. So I'm going to say the square root of 1 squared and 3 squared. This one is also 1 and 3. You could do that outside or inside the shape. It won't matter. So that's what I get, and that's that, and that, and it looks like they are equal lengths because they're both, that would be yes, because they're both equal to the square root of 10. Nice work, guys. All right, last question, number 5. Let's zoom on in. What type of quadrilateral is this? So it can't be a square because there's no 90-degree angles, right? It can't be a rhombus because that's all sides equal, and this one's quite a bit longer. It can't be a trapezoid because that's only one set of parallel lines. So again, just to kind of jog your memory, where like this one's parallel to that one, right? One set. So I'm going to pick D because it does appear as if these angles are congruent, these angles are congruent, so opposite angles are equal to one another, and these are parallel. So let's confirm that. What is the slope? If the opposite sides are parallel, then the slope of DE is, it looks like I rise 3, run 1. So that's my slope. What's the slope of GF? It looks like I rise 3, 1, run 1. Oh, sorry about that. Right? Rise 3, 1, 1. What is the slope of, now are these sides parallel? So we confirmed these are parallel. Now let's confirm these are parallel. A second set of lines parallel. So EF is rise 1, run 4. 1, 4. The slope of DG, what do we got here? Rise 1, run 4. Yep. So that's slope. So we are positively sure that opposite sides are parallel because they are the same slope.